Hello friends. Today learning is how to satisfy it all the axiom in group. There are four axioms in satisfy the group theory. The first is closure law, and the second is associative law, and the third is identity element, and the last is inverse element. The satisfy for the Cayley table use. Today question and today class understand the how to learn the Cayley table in satisfy in all the axiom in group theory. First we all show that the question is the set is 1 2 4 5 7 8. The count is 1 2 3 4 5 6 elements. This set under multiplication modulo 9 and it is satisfy is the group. I tell that is the four axiom is proved the group theory. First we all draw the Cayley table and starting the question is draw the Cayley table and it's very simple. The Cayley table is it all element it's written as first is 1 and 2 4 5 7 and 8 and it dot point operation is noted as how to apply the operation under multiplication and addition. The depend on your question is how to apply the operation. The given the question is the multiplication and apply the operation is under multiplication on modulo 9 and modulo 9 is a group. The modulo 9 it means that and the number of any Cayley table is less than 9 and any number is greater than 9, divided for the given question modulo and the remainder is answered. It answer it for Cayley table use. Starting the first element it multiply it all the elements number. The 1 multiplies 1 and 2 multiply by 2 1s are 2 4 1s are 4 5 7 and 8. The one is multiplied all the element and the second is use is 2 and the same method is all the element multiplied by 2. The 2 1s are 2 and 2 2s are 4. 2 1s are 2 and 2 2s are 4. 2 4s are 8 and 2 5s are 10. The 10 is greater than 9 and it divisor for the number. The rule is the 5 2s are 10 and 10 is divided and the divisor is the modulo 9. The given in the question and any is the other number for the other question is 9 4 5. The given in the question is 9. The 9 is the divisor and divided the sign. The remainder answer it less than 10 and 9. The answer is 1 and return is the 1 remainder. It is very easy for this method. And 7 2s are 14 and 14 and the 14 is the divisor is 9 and 14 is greater than 9. The divided and the answer is remainder 5 and the answer is 5 remainder and 8 2s are 16 and it divisor is 7. It is very simple and the third element is 4. For all the multiply and it any greater than is number 9. The divisor is answer. Divided the any calculator and the page side. 4 1s are 4 and 4 2s are 8, and 4 4s are 16, and 16 divisor is 16, remainder answer is 7, and the 7 4s are 7, 4 multiplied by, and the 4 multiplied by 5, 4 5 4s are 20, and 20 is greater than 9, so divisor is 9, and the answer remainder is 2. So the answer is given, the table is 2 remainder, and 7 4s are 28, and 20 is remainder is 1, and 8 4s are 32, 32 remainder is 5. So you satisfy 32 is greater than, so the divisor is 20 32 divide, and the answer divisor is 5, and the next number is 5, and 7, and 8. It's very simple. So 5 1 the 5, and 5 2 the 10, and 10 divisor is 1, and the 5 4 the 20, and 20 divisor is 2, and 5 5s are 25, and 25 divisor is 7, and 5 7s are 35, and 35 divisor is 8, because the greater than and it multiply 9 divisor, so the remainder answer is 8, and 8 5s are 40, and 14 divisor is 4. So this satisfy 40 is greater than, and the remainder answer is 4, and same as the 7 and 8, so the 7 ones are 7, 7 2s are 14, and 40 remainder is 5, and the 7 4s are 28, and 28 remainder is 1, and the 7 5s are 35, and 35 remainder is 8, and 7 7s are 49, and 49 remainder is 4, and 7 8s are 56, and 56 remainder is 2. So the last number is 8, and it multiply it all the number. 8 ones are 8, 8 twos are 16, and 16 remainder is 7, as the same is remainder 5, 4, and is 8 multiplied by 7, and the remainder answer is 2, and 8 is 64, so 64 remainder is 8 is 1. So you are satisfied 64, because it's greater than 9, and it not be the table is number of 64, for divided the divisor, and answer is remainder is given in this table. So all the number Cayley tables belong to this set, and 1 2 4 5 7 8, and all the number is satisfied in this set. So the first is prove the closure law for group property as closure law, and the statement is this law hold clearly from table, because all the multiple in the elements so satisfy this group. For example, is 4 multiplied by that, it dot sign its operation under multiplication. 4 2s are it multiplied by 8, and 8 it given is this table, and it Cayley table 8 8, and all the element multiply by 8, and the 7 multiplied by all the elements, so answer is 8, and the 5 is all the multiplying answer is 8, and 4 is all the multipliable answer is 8, 8 and 8 and 8. Now 8 times for multipliable, 8 times for 8. So first is very clearly satisfy, and second is the associative law. Associative law. So the any three number in this table, so 1 2 4 5 7 8. So let the three number consider is, let 2 4 and 5. So the associative law property is 2 4 multiplied by 5 equals 2, and 2 bracket is number 2 and 4 multiplied by 5. So the left hand side is 2, and 5 4s are 20, and 20 is greater than 9, and it divide is 24 the modulo 9, because the 20 is greater than 9, and 9 2s are 18, and the remainder answer is 2. So the 2 and it was 2, 4 2s are 8, and 8 multiplied by 5, 2 2s are 4, and 8 5s are 14, and 14 is greater than 9, so divided, and the remainder answer is 4. So the proof is associative law is satisfied in this Cayley table. So left hand side proof was to right hand side. So the two properties satisfy in this group, and the third property is identity element. And identity element, it means that it multiple is the any number, so the answer is same. For example, the 1 is identity element under multiplication. For any number is multiplied by 1, so the answer is same. Example is 1 is dotted operation under multiplication, and 4 and equals 2. Right hand side is 4 multiplied by 1. So the 4 ones are 4, and 4 ones are 4. So it is satisfied the third property, identity element. And 4 is belong this set, and 4 is belong this set, and 8 is belong to this set. So the satisfy in this property. And last property is the inverse element. And inverse in element, it means that the answer is 1 under multiplication, and under addition is 0 is inverse element, and under multiplication is 1. So thou satisfy, for example, is 1 multiplied by 1, and 1 multiplied 1 is answer is 1.